Good to see you guys. Well, I can't see you, but good to know you're there. And welcome everybody else. If I haven't met you before, my name is Jonah Sonner. I am a QSP and SciSec with WGR Southwest. And thank you for joining Stormwater Awareness Week 2021. This is our 10th year anniversary, I'm sure you've heard. And this class is going to be covering illicit discharge detection, pollution prevention, and good housekeeping topics for municipal staff. And this class is designed to meet the E7 training requirements of the Phase II MS4 Permit. So there might be some things in here. It's like, I wonder why that's in here. It's probably a permit requirement why that's in there. So again, thank you everybody for joining, and we're just going to dive right in talking about the Phase II permit real quick. Just a little bit of recap. The Phase II permit, if you guys are familiar with it, came out in 2013. It's been out for 8 years now, if you can believe that. We've been under that order for quite a while, almost a decade. It expired in 2018. It's a 5-year permit, and so we've just been in this continuing cycle of just continuing to implement the program as normal until the next permit's ready for us to be issued. Permit years, if you're, again, just
recap
it, are between July 1st and June 30th. And the program was phased in over 5 years. And a new one is coming. It's coming soon. Yeah, so again, just some basics here. Permit requires municipalities to annually assess staff's knowledge of illicit discharge response and provide refresher training as needed. That's why you all are here. It also requires each municipality to establish a biannual employee training program for staff involved in pollution prevention and good housekeeping practices, again, part of this class. It's required to include general stormwater education, operational changes, and BMP guidance, a biannual assessment of staff's knowledge of pollution prevention and good housekeeping techniques, and then also on your end, ensuring contractors that perform O&M activities to be required to comply with the same stormwater BMPs, and for you as a municipality to provide oversight for those activities. So you need to be aware of the best management practices that need to be implemented to oversee it well. So the class is in 3 parts. We'll do a quick Stormwater 101 coverage, then we'll jump into illicit discharge detection and elimination. And then we'll talk about at the end pollution prevention and good housekeeping techniques. Those are going to be our do's and don'ts for specific activities. And I'll also have some quiz questions included throughout. So if you want to go ahead, and I want to pull up my chat. Anytime this meeting, if there's a quiz question that I ask, go ahead and put your answer in the chat or put a thumbs up, thumbs down, and we'll see how everybody does. If you were in person, I'd give out brownies or something, but unfortunately, I can only give you a virtual brownie. So let's start with Stormwater 101. What is stormwater? Well, it is precipitation. That's the key word to remember. And precipitation doesn't just mean raindrop. It could also be ice and snow, or to a lesser extent, fog. If it produces water particles, then it would be considered precipitation. It disperses mainly by soaking into the soil, by ponding, evaporating, but the most common is it runs off to another location. And when we have stormwater runoff, you know, it's not a bad thing. We want stormwater to run off. We don't really want ponding. We don't want it soaking into the soil too much. So if it runs off, the problem with that is that it can pick up many harmful pollutants along the way. It can pick up sediment, it can pick up oil and grease from roadways, it can pick up spills that may have happened in a certain area. And so that's why everybody has stormwater regulations, because runoff if there's no BMPs put to it. It will go straight to a river, lake, or stream with no filtration, no treatment, and that can be a source of impairment for many of our rivers, lakes, and streams. So that's why we have BMPs. That's why we have these things to prevent pollution into waterways. Again, that's just some 101. But question is, how does stormwater runoff end up into receiving water? And that's mainly through a municipality's conveyance system. So that brings us to our first quiz question, if you're all awake and follow me. Which of the following would not be considered a part of the MS4 conveyance system? Is it A, park basin, B, streets and sidewalks, C, catch basins, D, none of the above? Which of these would not be considered part of the MS4 conveyance system? Go ahead and put it in the chat. Yeah, I see a couple options there. Yeah. Just making sure everybody's awake and participating. Yep, it looks like you're all awake. The answer is, if my presentation worked, D, none of the above. You guys got it right. Doing good so far. And why is it D? Well, the conveyance system is defined as a system that stormwater is routed through, which will ultimately discharge into a water of the United States and is operated by a public agency. It does include streets, catch basins, curbs and gutters, ditches, man-made channels, retention basins, and storm drains. So all of these things can be part of the conveyance system. That vegetated swale on the top left is part of the conveyance system. So is the concrete lined one on the top right. The retention basin is also considered part of the conveyance system. And so that would be, something we need to keep pollutants out of, as well as just the regular old storm drain. So another thing we want to just talk about real quick is just some terminology that I use. My wife always says I use too many words she doesn't understand. So let's put some definitions on here. Discharge, runoff that leaves a property, facility, or site and enters the MS4 conveyance system. And there's another term called a direct discharge. And depending on who you talk to, that might give somebody heartburn. But the general definition is a direct discharge is one that is directly routed to a receiving water through a pipe, channel, or ditch. There's nothing in between from where the catch basin is to where the outfall is. Oh, and what is an outfall? An outfall is a point source where an MS4 system discharges to the waters of the United States with no other conveyance systems. It's also the final point where runoff leaves a specific facility or site. Now, going back to direct discharge, it's fairly uncommon, for direct discharges, or direct discharges are not the normal in a lot of municipalities in the valley. If you're on a river like we are in city of Lodi, it might be the normal, but it might not be. We have a lot of retention basins that stop stormwater from going directly to a receiving water. But there are some storm drains that are piped directly to the river. So we do have some direct discharges here in Lodi. Now, other places, they might not have that. They might be far enough away. There's another area we work with, it's a county, where it takes quite a long route for the stormwater to travel before it will reach a river, even though it is still close to a river. Everything is graded away and flows opposite of it. So some more terminology is now non-stormwater. This would be considered, as the name implies, any discharge to the conveyance system that is not entirely comprised of stormwater. And there's two categories. We do have allowable non-stormwater discharges, and then we have illicit discharges, or non-allowable. And so these two categories, we will generally put a big blanket over it and say, if it's not stormwater, if it's not clean stormwater, it's not allowed to go into the storm drain. It can kind of get a little tricky with that. We do have a list of allowable discharges that we'll look at in a little bit. But just keep those two categories in your mind for now. Just you have allowable discharges and then illicit discharges. To prevent illicit discharges or to help reduce impact of pollution, we implement BMPs, or best management practices. These are practices or a combination of practices that are proven effective and practical to reduce or prevent the amount of pollution. And then there's two types for BMPs. They are structural or non-structural, or sometimes they're called procedural. And here we have our next quiz question, making sure everybody is still awake. Which of these is not an allowable non-stormwater discharge? Which of these is not considered an allowable non-stormwater discharge? Is it A, chlorinated pool water, B, discharges from emergency fire response, C, landscaping irrigation, or D, air conditioner condensate? I'm seeing some answers already. You guys are on it today. Which of these is not an allowable non-stormwater discharge? Good, good, good. Seeing some answers come through. And everybody got it right again. Look at that. It is chlorinated pool water. You guys are on it this morning. And why is it not allowable discharge? Well, because it has a pollutant. It has chlorine in it. Chlorine is a good thing, but too much will cause a problem in the waterway. We don't want to have our rivers be chlorinated as well. So let's do another one here. Which of these would not be considered a common pollutant? A little bit different question here. Is it A, sediment, B, trash, C, grass clippings, or D, pathogens? Which of these would not be considered a common pollutant? Seeing some answers for pathogens come through. Okay. Pathogens. Somebody changed their answer to C, grass clippings. Interesting. Okay. Well, the person who changed their answer to C would have gotten it right. Now, why is grass clippings not a common pollutant? Everybody mows their grass. Well, it's a little bit of a trick question, I will admit to you. I get these common stormwater pollutants from a guidance document, and they are considered, common stormwater pollutants are considered to be sediment and solids, trash, oil and grease, pathogens, bacteria, pesticide nitrates, and pH altering substances. Now you might say solids, well, grass can be a solid at times, or it might be considered trash depending on how you view your grass, but it's not necessarily a common pollutant. These are the ones that are a little bit more common. And again, this is a list from a guidance document. I don't remember if this comes from the permit off the top of my head, but these are the common stormwater pollutants that we want to be concerned about as we talk about illicit discharges. These are the things we want to keep out of our discharges. So here is another quiz question. What is an illicit discharge? Is it a stormwater discharge, discharge from potable water sources, residential car washing, or non-stormwater discharges? Which of these would be considered a illicit discharge? Seeing some answers for C, seeing some for D. Yep. Oh, somebody sent me all three. Okay, that's interesting. C, D, and B. I like it. It is, again, a little bit of a trick question. I'm going to say non-stormwater discharges because A, stormwater discharges are allowable as long as they're not carrying pollutants. B, discharges from potable water sources. That actually is on a list of allowable non-stormwater discharges. Maybe your municipality has that banned. They don't want that going in their conveyance system. but it's generally an allowable discharge. So is residential car washing. Now, commercial car washing is not an allowable discharge, but residential car washing is. But non-stormwater discharges, remember, we have two categories, allowable and non-allowable, and it's easier to say most non-stormwater discharges shouldn't be going down the storm drain. So a little bit of a trick question. I'm sorry. Any discharge, what is an illicit discharge? Any discharge of materials other than clean stormwater to the conveyance system, except for that list of allowable discharges. You should have a list of these in your municipal ordinances, but there are some other guidance documents that can tell you what a list of allowable discharges is, but this should have been done a few years ago and should be included in your municipal ordinances if you want to find those. So here we can see, I'll just run through these real quickly. We have waterline flushing and other discharges from potable water sources, incidental runoff from landscaped areas as unintended amounts. So your sprinklers are overflowing, that would be considered an allowable discharges if it does not carry pollutants like grass clippings. Rising groundwater, springs, passive foundation and footing drains, water from crawl space pumps and basement pumps, air conditioner condensate, natural flows from riparian habitats and wetlands, dechlorinated swimming pool discharges. Important to remember, it needs to be dechlorinated. Flows from fire suppression activities, fire hydrant flows. Waters not otherwise containing wastes, and there's a big definition to that. Diverted streams, uncontaminated groundwater. So you get the idea. It can't carry pollutants. That's the main thing. As long as it's clean, as long as it's just, if it doesn't have the potential to have many pollutants in it, it's probably safe to go down the storm drain. So we do have, oh, that slide didn't work too well. Some common illicit discharge sources and signs. Knowing that there are a list of common pollutants, we can have some common signs and sources that go along with that. One of the things you want to look out for is dry weather flows. If you're walking down the street and you hear water running in the storm drain by the sidewalk, and it's the middle of summer, there's probably a dry weather flow going on from somewhere. So the question is, where is that flow coming from? Where's the source of it? Is it carrying any pollutants? Is there anything we need to be concerned about? So illicit discharge is defined as a measurable flow during dry weather containing pollutants and/or pathogens. A storm drain with measurable flow but containing no pollutants is considered just a regular discharge. And that pollutant potential has to be determined through investigation, such as indicator monitoring. We're going to get into indicator monitoring in a little bit, but you can't just assume it is clean or not clean. You have to do some detective work. And there is no frequency. If it's a dry weather flow, it could happen at any point in time. You have no control over it. They have different frequencies, composition, mode of entry. They are unique every single time, unless it's a repeat offender. One of the most common illicit discharges is from a sanitary sewer overflow. That's probably the most common. A break in the line happened or something got plugged. It overflows and goes into the nearest drain and then out into wherever that drain ends up. A variety of monitoring techniques can be used to locate and eliminate illegal sewage connections or some breaks in the sewer line. These techniques trace flows from the stream or outfall and go back up the pipes and conveyance systems to find the problems. Illicit discharges of other pollutants are produced from specific source generated areas, or I'm sorry, specific source areas. Let me say that again. Other sources of pollutants are produced from specific source areas and operations known as generating sites. And these are more industrial and commercial facilities, typically, we will find. So some common discharge flow types, I mentioned sewage, but you also have wash water flow. That's a commercial, industrial, sometimes construction. Liquid waste flows and tap water flows. So we all know what sewage overflows. It's a, somebody had a buildup of fog and it overflowed. Somebody had a break in the line and it overflowed, and now is a sanitary sewer overflow. Wash water is generated from a wide variety of activities and operations. It could be from gray water from homeowners, commercial car wash wastewater that's legally piped, fleet washing, commercial laundry wastewater that might have detergents in it, those types of things. Floor washing to shop drains as well that may accidentally get piped into the storm drain system. Liquid wastes refers to a variety of flows such as oil, paint, processed water, or just water that is carrying pollutants. I would consider that just the general non-stormwater. If it's not stormwater, it's a liquid waste typically. Or you have tap water flows, which is from a leak or a break in a line from a potable water source that is now entering the storm drain system. And as I mentioned before, you have to do some detective work to determine, is it an illicit discharge? Is it an allowable discharge? And the way you do that is indicator monitoring. So we have this list of indicators that we will look at to determine what our discharge, what is making up our discharge. So we'll start with color. Is your discharge green? It's probably not allowable. But there's things in your discharge that can change the color. I guess I can go back here. You can see like this one over here, that white pipe probably has some paint or detergents in it. This bottom left picture, probably sediment or mud, maybe something else in there. So the color is a good indicator that there is a pollutant concern in your discharge, especially green water. Odors, does your water smell foul? Or on one project I work on, the water smells like grapes, and we found out that there was an illicit connection from a winery with their processed water. It was somehow piped into our storm drain system, and we would get fermented grape juice mixed with our stormwater, which was a lovely smell. Turbidity is another indicator. If it's muddy, if you just notice a lot of sediment in it, that's considered turbidity and is a source of pollution from somewhere, mostly construction. Sheens, this is oily substances or things like that. Floatables, it could be trash, it could be from sanitary sewer overflows, growth, weird growth or overgrowth on a pipe might be a sign of excessive nutrients or fertilizers that are going down the storm drain and are depositing around the pipe. And then staining or damage. If the pipe's dry, but you notice a weird corrosion or stain, there may be a common reoccurring illicit discharge in that area. Okay, so we have all of these indicators, and let's say we do find something that is an illicit discharge. Now, what do we do? Where do we go? How do we report it? What are the steps that we take? How much time do we have? So here's our scenario. John is performing storm drain stenciling. He's getting his face right in the storm drain. And as he just takes his normal breath, he notices there's a flow in that storm drain and it smells like fermented grapes. This is a story from real life, apparently. So when should an investigation begin? Should it begin immediately, within 24 hours, within 72 hours, or should he just forget about it? It's probably nothing. It's probably fine. Put your answers in the chat below. Seen a lot for A. A lot of people want to just take care of it immediately, and I respect that. And so yes, I would agree. Immediately is probably the best bet. You would want to start it immediately, but there's a reason why I'm saying 72 hours. It comes from the permit. We have a window of time when the investigation can start. Now, that being said, all three of these are important numbers to remember for reporting. So you guys are correct. You probably want to get on it as soon as you can, but you have 72 hours window if, these are the important things to remember, if that flow is not an immediate threat to human health or the environment. Now that can be subjective, but you would consider a sanitary sewer flow to be a threat to human health or the environment, probably more than a little bit of fermented grape juice. Maybe. It's a case-by-case basis. It depends on how severe the discharge is. But if it is a threat to human health or the environment, it needs to be reported and dealt with immediately. Drop what you're doing and just do it then. You have 24 hours to handle sanitary sewage or significantly contaminated discharges. Those need to be prioritized and investigated within 24 hours. But anything else, you're required to conduct investigations of all other sources suspected illicit discharges within 72 hours of becoming aware of the discharge. And again, key phrase to pull out here is becoming aware of the suspected discharge. When does that happen? So here's a quick flow chart just to walk us through these reporting requirements. We'll start just at the top left. Is the source of the discharge known? If we say yes, we can see it's my dear Aunt Sally's house down the street. We can see where the discharge is coming from. We could determine, is that discharge allowable? And if it is, we're done. We're good. We've done our step. We don't need to document it, or I'm sorry, we need to just document it and then move on. Now let's say it's not allowable. Let's say she's taken some gray water or some green water and thrown it down the storm drain. That would not be an allowable discharge. So now we have to begin an investigation and corrective action process, and probably talking to our dear Aunt Sally. But let's go back to the left. The source of the discharge isn't known. We'll say no. Then we need to perform indicator monitoring. Okay, so what is indicator monitoring? Well, we need to actually take samples. We need to see what constituents are in our stormwater or our discharge. So when we get our indicator monitoring back, then we need to see, is it within the action level concentrates, the ALCs, that are listed in the MS4 permit. If it is, we document it and no further action is required. But if it's not, then we need to, again, begin our investigation and corrective action process. So where in this flowchart would becoming aware of discharge happen? Where would it happen? Well, it would actually happen around the time that you know your sampling results. So you probably want to get them done as soon as possible, but that's the trigger. If you don't know what's in the water, that's when the trigger is going to happen. As soon as you become aware, hey, this is a contamination, we need to begin an investigation corrective action process. So it's a little bit confusing, but just try to remember those three different scenarios: the immediately, 24 hours, and 72 hours. So just to make sure everybody's still with me, another quiz question for you. Where can a list of allowable discharges be found? A, the MS4 Phase II Permit. B, on the municipality's website. C, in municipal ordinances. Or D, all of the above. What do you guys think? Where can I find a list of allowable discharges? Getting a couple answers in now. Some people are saying D. Anybody else? Yeah, I think Holly's got it for sure. A, you got it there. But possibly all, depending on a city. Yes, and it's a good practice to have them all in all of those locations. You want to know, you can find them in the permit. I don't know how many times I've just gone to a specific municipality's website just to look up something. So it's probably good just to have it on your stormwater page, but definitely in your ordinances, it needs to be there. So D is a safe bet, or I guess A and C are a safe bet. but D is a good practice. It's a good practice. So I've mentioned indicator monitoring a little bit. Let's talk about it here. So indicator monitoring is used to confirm illicit discharges and provide clues about their source or origin. And we are required to perform indicator monitoring at any outfalls where flow or ponding water is observed for more than 72 hours after the last rain event. So what that means is if it's been dry for about 3 days, and we go to our outfall and we see there's flow and there's ponding of water, we sample that and we take it off to the lab. We have a bunch of constituents that we look at. And then if it is above our ALCs, then we need to perform an investigation. So indicator monitoring should be utilized if the source of the non-stormwater flow is unknown. And so again, that 72 hours is often misinterpreted as sampling is required of stormwater after 72 hours, but it's just to provide a reasonable amount of time to make sure that it's not stormwater. This is not a stormwater flow. It's been 3 days. There's no rain, and it's non-stormwater. So I've been mentioning constituents. Here's a table from the permit of the constituents that we need to sample for in indicator monitoring. Ammonia, color, conductivity, detergents, fluoride, potentially, if you fluorinate your water, hardness, pH, potassium, and turbidity. Some of these you can do in the field, like ammonia, color, conductivity, but others like hardness, potassium, you can do hardness and potassium in the field. It's really complicated. You have a whole lab out that you're working on. But detergents and surfactants definitely needs to be done in the laboratory. So this is just to give you a reminder here, and then it also has some potential sources from these things. So let's say it's high in ammonia and detergents, it's probably sewage. If it's high in potassium, it might be industrial and commercial liquid wastewaters. If it's high in fluoride, it might be tap water, and those types of things. Then there's other dots that it has a 50% chance of being there, depending on the situation. But this is just a good table to help you identify illicit discharges again. So indicator monitoring can be performed in the field. You can use field instruments, or you can use a laboratory, depending on just what you want to do. Some tests, pH needs to be done in the field, needs to be done within 15 minutes of taking your sample. And so we take a hybrid approach for sampling. We do some field, some lab. And here is a list of those concentrate levels. And if you notice something, if you've been in the stormwater world for any amount of time, you'll probably notice that these are really high levels. Ammonia at 50 milligrams per liter is probably really bad. I don't know why it's that high. But turbidity of 1,000 NTUs, if you're familiar with the construction permit, you can't have turbidity discharging over 250 NTUs. So 1,000 is an extremely high benchmark. So the chances of a non-stormwater discharge to exceed one of these concentrate levels is actually fairly high. And I've rarely seen discharges be above these levels. I might have some constituents that are close to those levels, but it's really hard to break them. So this is just to say, again, it's to help us find the source of discharges, but it's not necessarily to penalize or to do anything like that. But this is just to help direct us in the idea to find a source of the discharge. And again, a reminder, aware is defined as when the municipality receives the analysis back from the lab. So that might be a 10-day turnaround. It might be a 5-day turnaround. You might pay for a 3-day turnaround. But that 72-hour window of beginning investigations happens when you become aware of the contaminant in your water. So just keep those things in mind. So once we've found what the discharge is containing, then we move on to some investigation. So we'll do what's called a trunk investigation. Basically, we'll start at the outfall and we'll move our way up. And we'll narrowing it down to a specific section you can see on the right-hand picture there. You know, you go to that third manhole, no flow, no obvious indicators. So you go back to that second, it's still there. So now you've narrowed it down to a neighborhood. It's in between those two drain inlets or that part of the trunk of the storm drain network. So you work your way up and then you branch your way out to look for a source of your illicit discharge. This is probably the most common one because here's the thing. If it's a small flow, it might be gone by the time you get your sampling results back. So doing some quick field analysis, you find there's a discharge, you drive up the trunk a little bit, see if you can find a source, an obvious source of the discharge. Doesn't take too long. For a bigger discharge or a more reoccurring discharge, you might want to do a drainage area investigation. You're looking at maps, you're looking at facilities, you're looking at your industrial and commercial inventory to see who might be discharging a specific type of wastewater or processed water into the storm drain illegally. Or you could do on-site investigations. So you could send cameras up the storm drain to see where it's coming from, where it terminates, or dye testing, which I think is really fun. You can start from a drain inlet and then prove that a discharge happened in that area by pouring some dye, some environmentally safe dye, and then going back to the outfall to see how long it takes and if that dye is present in the outfall. So once you determine that source of the spill, we need to stop the discharge if it's still occurring. We need to stop it as soon as possible. Determine the size and scope of the pollutant impact. Attempt to locate a responsible party if that's applicable. Sometimes the responsible party might be helping you find the discharge. They might not be aware of it. And then for each discharge, we need to develop a specific mitigation measure and timeline for the responsible party. Again, if applicable. If they're complying and working with you, maybe not as much. And then again, we field verify compliance with cleanup and mitigation. If they're not complying, we need to go through enforcements, notice of corrections, notice of violations, and of course, document. Document everything. Document the incident, document your actions, take pictures, go to the nines. So speaking about required documentation, I'm going to run through this pretty quick. Some things you want to keep, providing accurate flow measurements and duration of the spill and discharge that happens in your outfall investigation. Provide a map of the problem location, inlets involved, outfalls involved, where the discharge occurred, that storm drain, a field, stream, creek. You just want to show where that discharge occurred and where it ended up. Take photos of the event if possible. Photos are just a good timestamp. Like this, I was here at this time, at this day, and I have proof of it. Actions taken during the response, who you talked to, what equipment you moved, what activities you took, mitigation and cleanup measures taken, corrective actions, if you had enforcement, if you referred it to the water board, and then any follow-up field verification of compliance and mitigation. You want to document all of those things. So if you want to read up more on it, there's a couple, like all of this came from the Center for Watershed Protection's Illicit Discharge Detection and Elimination Guidance Manual. So if you need more, you can go to that manual for more tips, or you can go to Casca's Stormwater Handbook for Municipalities. I believe this is free. They have 2 good BMPs for responding to non-stormwater discharges and identifying, preventing, and responding to spills. So you can go and check those up right now. Excuse me. And now moving on to session 3 for pollution prevention and good housekeeping. And I didn't put this in here, but it's a good quote. An ounce of prevention is worth a pound of cure. And it's so true. It's so true. If you can prevent the spill from happening, if you can just take a small measure to set yourself up for success in pollution prevention or good housekeeping, you want to do it. It's a good idea. The best pollution prevention begins or starts before the job begins. It starts with an evaluation of your facility or whatever job you're doing and its pollution potential. So you could say, hey, I'm working on the river today. There's a high pollution potential. If I accidentally drop my gasoline can while I'm refilling my weed whacker along the riverbank, that's a high potential for pollution. If I am down the street or in a field and there's no drain inlets around me, that's a low pollution potential. So you want to observe your operations, what you're doing, fuel, washing, maintenance of material storage, understand your operations exposure to stormwater. Can you see the sky? You're exposed to stormwater. Understand how your facilities runoff flows and where it leaves the site. That's also important to know. How your site's graded, where it's going to discharge, where your site outfall is going to be. And then identify areas on a job site where water will run off and leave your work area. That's called the discharge point. Probably don't want to call it an outfall. Discharge point would be better. And so once we've identified the potential for pollution, then we can add BMPs to prevent that. As you recall, I said there's two types. There's structural and non-structural or procedural BMPs. So structural BMPs, overhead coverage. Hey, look, there's no exposure to stormwater. I'm good now. Secondary containment. You have something just to catch any spills or leaks of the container. Inlet protection devices. Plastic. You could protect that drain inlet from any spill that's happening. Or like a filtration bag or something like that. And then erosion control devices if you're working with sediment. You want to put some BMPs down for that. Those are examples of structural BMPs. Now, non-structural would be like procedures, inspecting. Hey, there's a problem here. Sweeping, knowing you're going to sweep on a specific schedule. That's a non-structural BMP. Material handling. If you handle fueling properly, you won't spill it. When I used to do landscaping, we would hold the can over the lawnmower, and when it flowed out of the gas tank, then we knew it was full. That's probably not a good BMP, having a spill every time you're filling up a lawnmower. You would probably want to stop before the lid overflowed, and that would be a better BMP. So don't do what I do. So again, as I said, we're going to go through some do's and don'ts, some things to remember when you're doing specific activities. So if you're working with vehicles and equipment, do as much as possible perform maintenance undercover. Do it inside if you can. That's not always possible. And sometimes you need to do that maintenance outdoors. So if you do maintenance outdoors, make sure you protect nearby storm drains and contain that maintenance as much as possible. Have spill prevention materials on hand, especially if you're working with liquid wastes like oil lines or hydraulic lines. Have some BMPs around there and protect nearby storm drains. You want to routinely inspect where you store vehicles and see if they're leaking or staining before you use that equipment or vehicle. Put a drip pan under it. Use absorbents as temporary fixes until maintenance can be performed. And then make sure you remove those drip pans and absorbents before it rains if you're outdoors. Don't be like this guy where he left all the oily parts on a piece of cardboard in the dirt outdoors. You don't want to do that. Make sure that's picked up before the next rain event. When you're doing washing, vehicle washing, maybe pressure washing of a building, don't wash vehicles or equipment near storm drains or other stormwater conveyance areas, and don't wash oily parts or other oily debris onto facility surfaces. Now, I have a bone with this because a lot of the construction inspections I perform, they perform equipment washing away from the storm drain inlet most of the time, but they are also washing things that have pollutants on them. Now, if you're just washing mud off of a piece of equipment or some things that are okay, that's fine. But if you have any chemicals on them, if you're washing paint brushes or stuff onto the ground, that's not allowed either. So again, take a look at what you're doing and look at its impact to storm drains if that was to run off, and reconsider that. So beyond oily parts, anything that has a chemical on it, don't wash that on a facility surface or ground. Make sure you're washing that in a designated area. Fueling, if you're doing refueling of vehicles or equipment, do identify storm drains in the fueling area and don't fuel over them. Have adequate spill kits present and clearly labeled. Make sure that they're not corroded. Sometimes when I'm doing my inspections, I check the spill kits and they're all dilapidated and grody looking, and they're not going to do any good. So make sure they are restocked and that you check those at a regular basis. You don't want to provide employees with access to the fueling area without training them on appropriate spill response protocols. Like me, when I did landscaping, probably should have told me to stop before the fill line. And then don't forget to routinely inspect, especially prior to rain events, for any drips and staining. Make sure to put absorbent down as soon as possible, as soon as you notice something. Right-of-way maintenance or doing road work. Do berm the area if runoff is a potential. So you can see here, this picture here, I don't know if you can see it. They're doing some water line maintenance. They are putting in some new things. So they have a little 5x5 hole here, and guess what? That hole filled up with water. And so where did that water go? Well, it went into the storm drain conveying system, and it has a lot of mud with it. And there's another storm drain over here underneath this car that all this muddy water is going to. So don't do that. If you have the potential for pollutants in your water, run it off, put some B&Ps in place to remove those pollutants before they get to a storm drain. And when they get there, make sure you have a protection on the storm drain as well. And again, keep spill supplies ready in case you need to use them. Some things that you don't want to do is don't store materials that could spill or cause pollution in the streets or gutters. Probably not a good idea to have your fuel can open in the storm drain where it could easily be knocked over. Don't wash vehicles and equipment at the job site, but rather in a designated area. This one is a strong one for me. If you have a wash rack that can handle pollutants in it, wash there. Try not to wash on your job site if it can be avoided. And then don't leave soil disturbed to stormwater when possible. Some trash and recycling management dues. I know it's difficult, but do keep bins covered when not in use. That is a requirement that we need to follow. If it's not being used and it has a lid, keep it covered. Do inspect bins to ensure that they're in good shape and free of leaks. Again, then if it's raining, you would probably want that bin covered. Do secure your bin to ensure only authorized personnel have access, so that you're not getting people just dumping stuff willy-nilly in there. Another good reason, have a lid and a working lock on there. And it just really, the reason behind it, it prevents rainwater from coming in contact with waste materials, potentially leaking out, because who hasn't seen a leaking trash can? If it gets water in there, it's going to leak out the bottom, and nobody wants that. And it's also having it being unsecured where anybody can have access to it. Somebody could dump hazardous waste in there, or something that's not supposed to go in the trash can in there, and then that's your problem to deal with. So securing it, keeping it locked, prevents all of those things. So some don'ts: don't place oily parts or debris in bins, don't empty liquids into trash and recycling bins, and don't store them where they have a potential to leak to nearby storm water conveyance system areas. So this picture over here is a good example. It has this weird color liquid in there. And they'd place some oily oily metal parts in there. It rained, and then they had that color. So when they were walking through the site, we noticed that it was leaking out the back of it and going off into a nearby storm drain inlet. And all of that could have been prevented if there was just a cover, if you were making sure what was being put in there was meant to be in there. All of those things, those are pollution prevention BMPs. Some BMPs for contractors to remember: check your contract language. Make sure that you specifically state in there that they're going to follow your stormwater BMP guidelines. Have some talks with the contractors to let them know your expectations. Walk the job site to show them the areas where they need to be concerned about runoff. Have facility signage just to remind people when you're not around that you're watching them. And then perform inspections. Make sure that they are doing what they say they're doing. So what happens if we do have a spill? What do? Well, we need to assess if is it a small spill, is it a large spill, is it hazardous, is it non-hazardous? And so depending on the spill material, if it's a small non-hazardous spill, we can just use a rag, a damp cloth, we can use some absorbent material for general cleanup, and then we can just sweep that up and dispose of that as needed. If we use water, it needs to be collected and properly disposed of. That cannot be allowed into the storm drain. And then we need to dispose of any waste material properly, just flat out. You can't put absorbent material in the trash can. It needs to be disposed of properly. And then clean or dispose of any equipment used to clean up the spill properly as well. Now, for a larger spill, we need to use absorbent materials for general cleanup of liquids again. But it might just be larger quantities. So we might have a lot of oil booms. We might have a lot of absorbent going down. Using brooms and shovels and street sweepers possibly for the cleanup of the dry materials. Again, if water is used, it needs to be collected and properly disposed of. And the same disposal rules apply here. It's just a larger area, larger amount of material, larger amount of material that needs to be disposed of. But for hazardous spills or very large spills, discharges, you might need to call a cleanup company. You might need to clean or reach out to somebody that does cleanup, that has a vac truck. If you don't have one, you might need a hazmat team depending on the spill. So this would be a good time to remind everybody that there is a spill response plan that has contacts. So you want to make sure those contacts are updated of who to contact. If you need a contractor, make sure those numbers are still good. If you need to contact county health department or the water board or somebody else, make sure those numbers are on there as well. So a good thing to go back and double check after this class. So if the spilled material is hazardous, then the used cleanup materials need to be considered hazardous as well and disposed of as hazardous waste. So that just adds to another line of work. You cannot dispose of it as non-hazardous. It needs to be labeled and treated as such. So pollution prevention, I'm going backwards, sorry. Pollution prevention starts with you. So remember, observe your operations, fueling, washing, maintenance, determine their exposure to stormwater, and understand how your facility, your area of work will flow if there's runoff, and where it leaves the site. Again, some more BMPs to look through. You can go back to Casca's BMP handbook. They have all kinds of guidance for different activities that are good to look back through and walk through. As well, the Center for Watershed Protection's Municipal Pollution Prevention Manual. They have a lot of other really good BMPs in there as well. So you want to check out both of those things. And with that, we finished on time with 5 minutes. So if anybody has any questions, feel free to unmute yourselves. If not, thanks for coming. And we have a couple other classes today. The one right after this, I believe at 9:30, is that Rebecca? is going to be about pesticides. So you hope to see you back for that one. So with that, are there any questions? Okay. Well, you can always get a hold of me if you need me. My contact information is there. Thank you, everybody, for joining, and hope to see you around for another Stormwater Awareness Week class workshop today. Thank you so much.